Are in listen-only mode.
Good morning, ladies and gentlemen, and or afternoon, wherever you may be. We want to welcome to this month of Passive Virtualization Virtual Chapter Meeting. If you have not signed up for Summit yet and you would still like to sign up, you can do so. There is on virtualization.sequelpass.org, there is a number up there that can get you $150 off. If you are coming, stop by the community zone and come see me. I will be there early in the morning when you enter in for breakfast. So each day. So come by and see me, and of course I'll be throughout. So I'd like to meet as many of you as I can. Today we have Bali. He's going to be talking to us about deploying SQL Server to an Azure VM. And Bali, we want to thank you. This is a very timely subject because many of us are kind of looking at this now. So I'm going to go ahead and pass it over to you.
Thank you. Hi, this is Bala. My full name is Bala Krishnan Shankar, but people call me Bala. I am with Microsoft for the last 12 years. The last 3 or 4 years, I'm working on SQL on Azure Virtual Machine. And this is the presentation I'm doing based on my experience with various customers, trying to give a bigger perspective in terms of deploying SQL on Azure Virtual Machine. What are the key facts you'll need to consider and go forward. Now, before I start the session, I would like to give a credit to my peers. Most likely, you guys already know Bob Watt and Keith Elmore, who I closely work with him on the same building. I'm based out of Dallas in Texas. This is a 1-hour talk, and I did this session on the SQL Saturday in Dallas as well as in Oklahoma. The same topic I'm planning to present in the past too, but I'm going to change a lot of things for the past. To give much more deeper dive, but this is going to be on a high level, how to deploy SQL and what are the things you need to consider for. So before I jump on, I would request you to keep your question. If it's going to be a lengthy question, I would love to keep it at the end. But if you have a quick question, you feel, hey, I cannot move forward without the answers, please raise the question. I'll be able to answer the question. The idea of this whole session, or I would say the takeaway of the whole session, is 3 points, which I want to convey. 1, what is actually SQL on Azure Virtual Machine? What is it different? That's the one I wanted to explain you guys. 2, when you deploy SQL on Azure Virtual Machine, what are the key factors and consideration you need to do? And when you get out of this session, you should be able to think SQL is on a VM in the cloud. That's the objective of this whole session. We will talk about what are the different offerings and what are the different ways you can deploy SQL on Azure Virtual Machine, and what are the things you need to configure for optimal performance, and how do you go and deploy AlwaysOn and even deploy in hybrid scenarios. That's what we're going to go and deep dive in it. So before we jump on, if it's an interactive, I would love to ask this question, is how do you know cloud? So before I say theoretically and all those stuff, I'm going to jump on to showing you a demo and explain you how easy to deploy SQL on a virtual machine. So this is my Azure portal. You can use portal.azure.com, or you can go to any search and you for azure.com. You should be able to route to this portal. This portal is what we call a new portal. We call a ARM portal. People use ARM portal, classic portal, and new portal. This is a new portal. There is one more portal called classic, which is called manage.azure, windowsazure.com. This used to be the portal in the past, like in a year back or something. But there are certain features still there in the Windows Azure. The primary would be Azure Active Directory. So for any other stuff, you would be, or primarily for SQL Server related stuff, you should be using the portal.azure.com, and it has all the services on the left. And we are going to use the virtual machine too. So what I wanted to show you is how easy to deploy. So if you click on Add here, and it's a walkthrough, it's a wizard. You should be able to select whatever image you want. So let's say SQL Server 2012, and I should be able to search for it, and these are the different images Microsoft product as published. So we publish different templates for you. So these are the different versions and edition of SQL Server. So I'm going to choose SQL 2016 RTM because the reason developer is a free of cost. You don't pay for SQL Server license, you only pay for the Windows license. So I'm going to use the developer. It's same as the enterprise. So I'm going to create it. When you click on create it, it's going to ask a couple of questions. The main question would be, what is the name of your VM or SQL server name, basically. So I'm going to keep it simple. So I've typing, if you simple inputs which are self-explanatory. So these are all at the VM layer. So the name of the VM, and you're saying this is the user ID for the VM, and this is my password for the VM. And here is where you're going to choose whether you want to use a resource group deployment model or a classic deployment model. So if you already want to join to an existing resource group, you should be able to use existing deployment model. For now, I'm going to create a new one for us. I can choose the data center, and the password is something. So the first section, the basic section, is for the VM, that Windows layer VM. This next section is going to ask you, hey, I know you're trying to deploy a VM. What size of the VM you want to deploy, right? There are different families, we call it. We will dig into it. What are the different families? Right now I'm just going and selecting a version called D2 V2. It's a size. Each size has different specs, like what we saw. We'll talk about all those stuff. So I'm going to click on OK with the default settings, just to give you the perspective how easy to go and deploy a VM. And that's it. So I clicked basically 6 click of OK button. After typing like initial of 7 parameter, it started deploying the thing. And if I see it says deployment started and I click on it, it's going to show me the different stages of deployments, and what are the different parameters it's using to deploy. This is how fast you can deploy. You can come back in, let's say, 15-20 minutes. Your VM should be available, accessible for you with SQL in it, and you can use your SQL server like your on-premise or any other SQL server you're used to. So this is how the easiest way you can deploy. But we are going to talk about what are the different offering we have got from an Azure perspective, right? So if the reason is, when I speak to different customers every other day, they basically have different perspective of understanding because of the terminologies used in various places. So if you ask me, very simple, the SQL on Azure VM is basically an infrastructure as service. The infrastructure service is going to give you a virtual machine in which you are hosting. We are hosting your virtual machine. You specify what virtual machine you want to deploy, and that's what we are hosting on our hardware. The next one is we are basically giving you all different platform features which will help you to make sure your VM is always available. We have created a platform which will help you to define how it can handle a failure of the VM level, and it can recover your VM back with not many downtime or much downtime for you. So this platform also helps you to uh, control what you want to share control to Microsoft. So as soon as you deploy a VM, the VM is fully controlled by you. The guest OS or the VM is fully controlled by you. We do not even have access to your VM. We just only know that this is a VM running and this is the size VM. We do not have access to the VM. And we don't know what applications you're running inside the VM. It could be a SQL VM, it could be any VM, you can install whatever application you want inside the SQL VM. It's up to you. So that's why you get a control of the VM like your on-premise world. You are responsible for making sure SQL high availability is taken care. From a VM level, the Azure platform is going to give you the high availability in the sense that it'll make sure if there is something wrong on the VM or the hosting the VM, it's going to fail over and bring the VM back online. But from a SQL perspective, it's up to you. You need to choose your own HA solutions. Now, to give you a pictorial depictions, if you see the hardware, the physical disk is owned and controlled by Microsoft. We host those information. We host the host of the VM, and you control the VM, the virtual machine. You control what version of SQL Server, what patches of SQL Server you want, how many database you want to create. All these things are fully controlled by you. We do not have any access to it. Now, this is we call as an infrastructure as service. Now, if you come down to the Azure database perspective, the Azure database is a PaaS service which we provide, and here we change what you control and what we control. We abstract the physical layer of the SQL Server, like where do we put the SQL Server files, how much of size I need to provide, what size of disk I need to have. All those questions are all sorry guys, are all is fully taken care for us. I'm going to make it, sorry, okay, are all taken care for you. Now you are going to create your database just like going to a page and say, hey, create a database for you, and that's what you're going to do. And you don't worry about the physical storage, what kind of instance it is, what version of SQL Server it is. You don't really worry about it. You're just worried about your database, and you are worried about the performance and the high availability of it. So the platform takes care of auto HAing it, or it'll take care of configuring your auto HA. If the one of the site is down, it automatically can route to the connection to the other side, and you don't need to worry about how do I set up auto HA for SQL Azure database. This we call as a PaaS model, and here our our hardware is taken care by us, network is taken by us, the VM or the host machine of the VM is also owned by Microsoft. The VM is owned by us, and the SQL Server version is again controlled by us. It's just that you will be worried only about the database and the SQL Server. This is we call the SQL Azure SQL database. We had many different names in the past. Now we call Azure SQL database, and this is a PaaS service model. Now, in this session, we are only focused on SQL Server on Azure Virtual Machine. So what are the things we are going to, so if we think about provisioning, right? You provisioned the VM using the management portal. Just now we clicked 5 clicks and we got the VM provision. Now that is one method you can deploy. In that method, we chose an image. We call it a gallery image or market images. These are terminologies you will hear. So you chose an image. Hey, I want 2016 with developer edition. That's the image. So when you select that image is associated to the VM and it deploys for it. So you do not install any SQL Server from there. You can also provision a simple Windows machine and bring your own media, SQL Server media, and install yourself like any other on-premise VM or on-premise server. That is also possible. Now, you can also bring your own VM. Let's say I have a VM with SQL Server in it, and I want to just do a lift and shift where I want to move my current workload from your on-premise world to Azure VM. Yes, you can also do it. That requires some additional steps. That is a customization where you will have to do something called sysprep. So if you have done in the past, a sysprep is a command tool which will help you to remove certain identity information from the windows. Like for example, Windows identity credentials and passwords and all those stuff specific to that VM will be removed. And it makes a generalizing that VM where you can use the generalized VM to deploy multiple VM. It's kind of a template. You can do that. Now, when you do that, you are bringing your own SQL licenses to the Azure platform. You can copy that particular VM by using a VHD copy and put it there, and you can definitely deploy a VM on top of it. The one difference, the main difference between is the image gallery, you are basically subscribing or purchasing to a monthly pay-as-you-go license. As soon as I selected a 2016 Enterprise Edition or Standard Edition, we have a different pricing model, and that pricing model will apply as soon as you select that VM and deploy. Now, the pricing model would also charge per hour basis. For example, you can deploy a VM, start the VM and run it for, let's say, 5 hours, and you shut it down from the portal. The charge would be only for that 5 hours. You won't be paying for the anything which you are in shutdown. Now, when we say shutdown, we are talking about stopping the VM from the portal. Let me show you that piece. So if you look at it in my portal, I have these VMs are in stopped state. Even though this is a SQL VM, I've stopped it and I kept it in a, as soon as you stop it from the portal, when I say stop it, when you click on it here and you go and say, you will get the option. You will get the option, should I stop it? Should I restart it? So when you stop this from this particular portal, what this portal in the background is doing is basically, as soon as you stop, the platform who is deallocating certain resources like compute resources. It's deallocating your network card resources, is deallocating your network usage resources. Everything is deallocated. Your public IP. So any VM you deploy gets an IP addresses associated to it. For example, this is IP, right? This public IP is deallocated, which means this IP can be reused for any other customers. So all these resources deallocated, and that's how we ensure we don't consume resources and we don't charge our customers. So you can stop, and I do have many customers who bring up their workload for specific actions. For example, one of my customer has some kind of routing algorithm where he does routing for school buses. He basically brings the VM online in the morning, like 4 o'clock in the morning. He does the routing and he shuts down by 9. And after that, he brings it next day morning and shuts down by 9. So an enterprise license, SQL Server license, and you bring it up for like 4 hours a day, and you get the cost only when you use that license, not when it is not used. When I say not used, you should deallocate it in order to not get charged for you. The important thing is when you deallocate, your disk is not getting deallocated. It is still there in the Azure storage account. The storage account, you can use that file copy to anywhere you want. You can download. When I say storage account, let me show you. When I say storage account, the storage account, if you look at it here, this is what the disk associated to it. This is part of, is stored in Azure storage. This is stored in this particular storage account. So you still have that image anytime you can bring it online. So anytime you can bring it online. So that's where you will gain most of your costs reduced by bringing that down. Now, when you bring your own VM and you install, you are bringing your license. Now, not every license can be ported to Azure. You would have to have something called license mobility in there. And when you bring that license, you can install your VM and you can run your VM. You're not going to be charged for SQL license, but you will be charged for the Windows-based machine license, which as soon as you create the VM, you're going to be charged for it. So this requires your own license. And so these are the different ways you can deploy. Now, we talked about the VM sizes. There are different families of sizes available on Azure. This family keeps on growing. If you go and check today, you will have an additionally added. If you come back after a month, you will get a different family added to it, different spec added to it. So it's a growing size of VM you will get. Now, to simplify the understanding, so there are 4 different families of VMs available for you to start with. One is A and D series families, and a G series family, we call it as a Godzilla family series, and we have something called DSV2 or a DS series family. And finally, we got a GS series family. So these are the 4 different categories or families you will see on the portal. Now, each individual family can have different sizes. For example, A2, A3, A4, you can keep on growing up. Those different sizes will give you different spec. For example, one would give you 2 core, the other will give you 8 core, and different specs are there for it. So for SQL workload, we do not recommend to use A and D series family. We do not want any of our customers to use A and D series family. I'll dive into why we say that. The other one is called GS series family, which is also not really meant for SQL workload. This is meant mostly for a CPU bound, or I would say a very heavy CPU bound workload on that. And we use most of our, my experience and whatever I've seen is most of our customers uses the DS series machine. The DS stands for DSV2 is the next version of DS, so that's why we have DSV2. The reason we recommend the DS2 series machine is that DS series machine U is compatible for low compatible for premium disk or something called SSD drives, um, which you can attach, and you can define how much of storage you want, and it is meant for SQL workload. That's why we recommend to use DS series machine. And the GS also is compatible for premium storage, but it also includes a big heavy compute cost. So it's definitely an expensive VM if you are talking about, and I have many high-end customers, like big customers using GS series machines too. So if you're talking about an entry level, an average SQL workload, you can start with DS series machines and you can pump up. The one key differentiates is between the VMS, just to show you, right? So this is the VM. This VM I have right now is the size of DB2 machine. Okay. Now within this family, because it's a D family machine, I can choose and change the size, any of this size, anytime. I can say, hey, I need more CPU power. I can change this to D34, and I say select, and that's it. It'll upgrade my VM size to D3 machine. So if you see, this upgrade is only within the family or compatible family, not beyond the compatible family. What I mean is, if you see, you will not find a DS series machines at all. You will only find D, and you will find F, you will find A. These are all like a tier 1, or I would say A series, D series, so F series. So these are the series you will be able to compatible, but you won't be able to upgrade it to Godzilla series machine, or you won't be able to upgrade it to a DS series machine. But within the family, you can reduce it or upgrade it. You can do it. It's on the fly. If you set it, it needs to restart, and after the restart, you will find the respective core and the size of the memory and how many disk you can attach and what all you can do. You can do with the newer version of it. So that's the important thing about the VM on Azure VM. So these are the different VM. So we so if you made a choice, let's say I have many customers who said, hey, mine was a small VM, so I started with the A2 machine. Now if you made a choice, how do I upgrade to? Because I told that you cannot upgrade from an A machine to a DS machine. So you have to redeploy the VM. There is no way you can in place upgrade the VM from A series to DS series. You have to redeploy. Now, when we talk about redeploy, yes, you might have a downtime, but you can minimize the downtime by doing certain recommended operations, which will help you to reduce the downtime. You can copy the whole VHD to a new storage account, where if you want to upgrade it to, let's say, DS machine, you can just copy the files, the VHD file, and create a VM out of an existing VHD, which will take like 15-20 minutes to create a VM out of it. You can do that too. Or if you say, hey, I don't want to even go for a 5-minute downtime, I want to be very seamless, less than 5 minutes, then you can go and create another VM, set up a SQL AlwaysOn or a database mirroring between these two guys, and then just fail over that option. So you have to change that option. Now, if you want to uh, read the complete list of tables, it's there in the link. That this link gives you a complete list of sizes available for you. If you scroll down, these are the different families. If you see, we have these many families. We have added recently H series machines, so it gives you how many cores you'll get and how the ACU cores are calculated. And here is where I was talking about the DS, right? So it gives you, this is a CPU, how much memory you will get, what is the local disk size you will get, that C drive will get, and what is the number of disks you can attach. We are talking about number because you can attach 1 terabyte disk, you can attach 16 terabytes on this machine, you can attach 32 terabyte of this machine, and you will get the throughput of the disk IO. You will get these many IOPS, 500 IOPS, because every disk, a standard disk, gives you 500 IOPS. You can go up to this IOP, and it has a network. So it has detailed stuff about what is available and what kind of limitations or max limits of resource available for each individual size. This list will give you that. Now let me go back to this page. Okay, now what are the choice? Yes, we talked about administrator account, the deployment model. Now I didn't go detail about ARM deployment and classic deployment. The intention is to, because it's a separate topic which I wanted to cover in a short form, but the ARM deployment was released, or I would say got released probably 7 or 8 months back and a year back, most likely. Before that, we used to have a deployment called classic model. What does a classic model? The classic model is basically meant to manage a single resource. So if you deploy a VM, that is managed as that a resource. You cannot do control as a group of resources. In the ARM deployment, think of it a container. I can create a deployment model and I say, hey, on this model, this is my group called ABC. In this ABC, I'm going to have a web server, I'm going to have a SQL server, I'm going to have a reporting server, I'm going to have some analysis server. You can create as a separate unit of work and you can redeploy. Let's say I wanted to just to show you that options, let me show you. So if you see, this is the resource group. When I click on this resource group, it contains all these resources for me. On the right, if you see, these are the different resources I got. If you see, this is my network, this is my network, this is my storage, and this is something called availability set. I'll talk about that. This is all my VMs, and this is my BNet virtual network connections between two data center, North Central and South Central. And this is my load balancer object, and these are the different network cards for my VM. So these can be redeployed as a single unit. So if I go to this deployment tab, I can basically say, I want the whole thing to redeploy a drop, take a backup of this deployment as a template, and redeploy the whole thing as a one unit, which will give me a complete resource management in terms of cost for a specific application type or cost for a specific department. And I can set, I can do a lot of automations. It's more about managing a set of resources to a container scenario. So that would help you to manage the resource. Now in the old classic model, if I go to here, this classic model, if you see, this model as one single VM, and this VM had to be managed and redeploy as one unit. So if I have an application which requires 10 VM, I needed to deploy 10 times to deploy this rather than one go at a time. And there are access control and all those stuff I have to do individually rather than as a container. So that's the new model of Azure Classic deployment model we talked about, and that's going to be the future of Azure ARM deployment model. So if you are planning for any new deployment, ensure you use ARM deployment model. In the classic model, we didn't have to use a virtual network. In the ARM deployment, you have to create a virtual network requirement in the SQL Server VM world. So, and then you will choose a DNS label, what is the network name of it, and you will see what is a virtual network. Now, the virtual network, and if you guys, I'm pretty sure you might have, it was so fast. So if I go here and I'm trying to see my VM which we deployed, uh, so if you see this VM is part of a virtual network. This virtual network is something your infrastructure guys used to do it in the past. I mean, on-premise world or something, somebody would give you a network and you deploy it on the network. Nobody even worried about it. But in the Azure world, you definitely need to know what you are going to deploy as a whole in terms of overall solution per se from SQL Server, so that you can deploy SQL Server within the subnet, or you want to connect a subnet and all those stuff. So knowing the address space or defining the address space here, what I'm talking about, is very critical when you deploy. So keep in mind when you are planning to deploy a complete workload, just make sure the address space is considered, thought about it before you deploy, because once you deployed it, you cannot change the address space. That's the network. So you are going to use a storage account. So the storage account, let me go back again here, and the storage account, this is my storage account. This is called storage account, and if you click on this, I have so many storage here. So if I click on add, this storage account comes back. Think of like a service. This storage account is basically a service. It's not a physical storage or something. This is a distribution file system model. So you will specify what is my storage account. This is where your all the VHDs or disk or files you can store. Now this comes with different types of storage performance. One is a standard, one is a premium. We recommend to use premium storage for SQL workload, because a standard and premium gives a different SLA altogether. If you want to know more, if you click on here, it will going to take you to the premium storage workload link itself to you. It'll talk about what is the storage service and how it's set, what are the different type of storage you will get, and all those stuff. So SQL Server uses a blob type storage, which is basically a VHD in the background. The reason we want a premium storage is gives you a lot of SLA in terms of latency. Now, if you think about IOPS versus latency, I can say I can do an IOPS of, let's say, 10K IOPS is different from saying I have 5 millisecond latency of an IO. It's two different. One is measuring how long I'm going to take to complete a single IO versus overall throughput of the IO. I always relate that to a Walmart scenario. I can say Walmart store can handle 5,000 customers a second. That doesn't mean that a single counter, if I go and stand in the counter, I will be able to get out in a second. Right? That's how I relay that. I have to consider how many customers are in front of me, how much of container or the cart contains how much of material they are buying will define how long I'm going to wait in the queue. Now, I can definitely process 10 customers, or I'd say 1,000 customers a second with 20 different counters. But if you think about SQL Server is going to post an IO and has to wait for you to fetch the data for you. Now, there are caching in SQL Server, but if it becomes a physical IO, it has to heavily depend on the latency piece, because how fast the latency comes back is what it's going to reflect how much of performance you're going to gain out of it. So the premium storage is where we want you to use, because the premium storage by default gives an SLA of a read latency of less than 10 milliseconds and write latency of 10 milliseconds. So, and also gives you an option to, in terms of SLA on that. A standard storage does not give you an SLA guarantee of latency but premium gives you an SLA guarantee. You can call us and say, hey, storage account is really not working as you guys said. You can definitely ask for our billing issues and all those stuff. So that is an SLA in terms of it. Now this has a huge potential. It can handle 50 gigabits per second inbound and outbound. That's a huge number if you think about it. And it can give you a scenario where a VM, you can have 80,000 IOPS. And now you might ask me, hey, now you're talking about an IOPS. Now within that latency, the premium storage can give that 80,000 IOPS on a single VM, which is so huge. And in order to create a VM on your on-premise world or any other world is definitely a lengthy conversation you need to have to your business to justify it. But you can create this VM and you can basically use a heavy workload a monthly once and shut it down. It's not going to cost you a lot of money. However, the premium storage pricing model is different in terms of standard. Standard uses a pricing model of you attach a 1 terabyte disk. Doesn't mean you're going to pay for 1 terabyte. You're going to only pay for the usage of the disk. Let's say you attach and format a disk, quick format, and you only stored like 10 gig in that particular drive. You're going to only be charged for the 10 gig for that usage. But for a premium disk comes with 3 flavors: P10, P20, and P30. P10 comes with 128 gig drive, and P30 comes with 1 terabyte, and P20 comes with half a terabyte. Now each one comes with a fixed cost. It costs from like $300 to all the way to $600. Now that price keeps on changing. So yes, that comes with a fixed. As soon as you attach, you are going to be charged for it. That's the major caveat. But if you think about it, if SQL is heavily dependent on IO, that's where you want to spend your money if you're planning to deploy a VM, because that's going to give you more buck out of the money you paid for. And the more important stuff, because we are talking about high available, because high availability has to be configured by the customers or users. So when you deploy, you need to make sure your VM is part of something called availability set. What is an availability set? An availability set is a way to tell the Azure platform that this VM should be made sure not put in the same hardware cluster. If you visualize, if you deploy a VM, it goes to one of the rack in the data center. Now that rack has many point of failure: a network card failure, a power failure, or a VM OS crash, or it could be a SQL Server crash. Anything, it can happen, right? Now there is no way anybody in the world can guarantee that this rack will never fail. It will fail. Now how we handle without affecting of your business is what makes the platform much more stable, right? Now in order to do that, we have to deploy a VM within the availability set. Now, from a Windows layer perspective, in order to get 99.99 percentile of availability, you need to deploy within the availability set. What does it mean? It means that you need to deploy 2 VMs. We will make sure that these 2 VMs are not part of the same rack. If one of the VM goes for the task, it could be for the fault, or it could be for the update in the sense your host has to go through an update process. It goes through a cycle every day and day out. If it updates and it has to recycle your VM, it will not recycle both the VM together. It will make sure one of the VM is always available. So if you think about a stateless application like a web server or something, your web server can go down without worry about it, because the VM can be brought online, other node, other cluster. Yeah. However, your SQL Server is not like that. It's a stateful application. So you need to make sure from a SQL Server is also handles that statefulness perfectly. That's why we would recommend you to use AlwaysOn availability group and use the availability set together to get your highly available. And the other one is NSG. So when you deploy VM, this is by default puts you into the publicly internet accessible VM. So ensure your VM is controlled using the NSG. By default, we will enable RDP port, but any port you want to expose, you are going to go and create the NSG for it. Now, what is the NSG? Network Security Group. That's what it means. So I can show you that quickly. So this network card is associated to this network security group. This security group has inbound rule and outbound rule. The inbound rule right now, if you see, I have something called RDP, the default, and I have added something called SQL probe with the port number 5997, 5996, which means I can directly telnet to this 5997 outside over the internet. That's what it means. Yes, if your VM is not exposed inside the Windows firewall, it won't route, but in order to even to reach this VM, you need to have this inbound rule. Now, if you don't have any inbound rule, you won't be able to reach it. But for SQL VM, we don't want to have any SQL connecting over the internet unless you have a specific requirement. Ensure that you configure the rule appropriately. So this rule has many different structures. You can specify um, um, different protocol, you can specify a range, firewall rule, and all those stuff. So you can definitely do all those stuff. Ensure that you do that, because I've seen many customers calling us and saying, hey, somebody is trying to connect to my SQL server. So ensure that is not happening. So what next? So you will have an RDP connect, and you can configure your SQL server. Now, when you deploy, make sure the storage decisions are perfectly configured. So these are the storage configuration you need to make. One is the how much of IOPS you need for your VM. You need to identify that, and you need to ensure the bytes and bandwidth restrictions. So anytime you attach a disk, it has the max. So this is what I was talking about. The VM has IOPS limit, throttling limit. We call it as a throttling limit. What is the max disk throughput it can associate? So if you have a VM which is DS3 and it cannot go beyond, as soon as it goes beyond, we are going to throttle you. We are not going to let you do that. We are going to throttle you, which will create a performance problem. So you need to ensure this is not hitting your VM. And make sure you have a minimum of 2 premium disk, P30 disk, which will give you 2 terabyte of disk, and it'll give you 5,000 IOPS of throughput with less than 10 milliseconds latency for read and 10 milliseconds for write. And ensure you use storage pool. This is a concept called storage spaces, which is a Windows 2012 feature where you can pool a set of disk and make it as a one logical volume out of it, which will help you to achieve a higher throughput capacity for a single disk. And enable recaching. So when you talk about disk, you have a property called enable recaching on a disk, enable recaching for the premium disk, and when you format, ensure you use 64K NTFS allocation unit size. Now, the good important thing is this all this setting is managed by the Azure portal itself. When you deploy a gallery image, we take care of all these stuff for you. On the page, if I go to a SQL VM, and that VM will have something called SQL configuration page, and that page will tell you that it is set for that. Okay. So this is the VM I deployed, and if you see, which we started with the VC demo, and it will tell you something called SQL configuration page, and this page will have the various settings which we implemented when you choose a gallery image. So it tells you the storage usage. It's a dev machine. It's a storage. Yes, this is a connectivity settings you have done. You have not enabled auto patching. You have not enabled auto backup. So you can do all other stuff, but we take care of configuring when you deploy the VM of all these settings. During the prompt, you can do all those configurations. That's what I'm trying to say. Now, enable instance installation file. Now, if you're a SQL Server guy, you might know what I'm talking about. This is a permission which helps the SQL Server to grow the file faster in a simpler form. It will ensure that it doesn't do zeroing a file in the OS layer when you grow the file. Let's say if you're growing a file from 1 gig to, let's say, 50 gig, then SQL Server has to make sure that all AK pages within that 49 gig has to be zeroed out, and then let you to complete the transaction. So this permission will help us to make the file grow faster and avoid reaching the throttling limit on the Azure world, because if you think about it, that's the only workload it's going to push your IO. That's why we want this permission to be enabled, so that we do not do zeroing of file in one shot. We will do it in an incremental fashion as and when we require it. That will help us to balance your auto file growth, and your IO optimization. Now enable lock pages memory. Ensure that you enable lock pages memory and turn off geo-replication. For SQL Server, you don't need a storage account to be geo-replicated. So if you want to check out all the various performance best practices, we do have a link which we keep track of, and we publish every day, and we will update every other week any changes we have. This is the page which you can access to keep you up to date on the best practice recommendation. Okay, that will help you to avoid any wrong configuration for it. So in terms of connectivity, right, you have two options. One is you want to let the internet connect. You want to connect SQL Server over the internet or not. If you want, you need to make sure you have a public interface, like what I showed you earlier, and you ensure the SQL port is created with the NSG. That's what it is, and you ensure that SQL authentication is enabled for you. If not, you will get an authentication failure. And ensure your Windows firewall is also have an exception for 1433 if it's a default SQL Server you're trying to connect to. And you can also enable internal load balancing if you want to. Now, in terms of validating, ensure you have a connectivity and network latency is compatible for your application. Ensure you have a required IOPS. So to give you an level of estimation of an IOPS, you can say for an index operation, you can say 4 to 6K. For a checkpoint, you can say 1 to 2K. A read ahead process which SQL Server takes care in the background for certain operations you do. So you can say 300 to 500, and CheckDB requires 1K. So all these things will require certain number of IOPS. So when you plan a VM, ensure that you consider this. And you can also use a perfmon tool to look at average disk seconds per transfer to estimate your IO requirement from your current workload if you're planning to deploy and you're migrating an existing workload. Any tools you have used in our environment, you can use it on Azure VM. Nobody's going to stop you on that. Now, this is a new feature on the SQL IIS extension world, which is basically, these are the three different components. We call it a SQL IIS extension. And this gives you two options. One is called SQL Automated Backup. One is called SQL Automated Patching. So we got a lot of feedback from various customers that, hey, this Azure VM, we are not a DBA guys. We are an application. We know certain SQL Server operation, but not a DBA. We don't want to spend too much time in managing our database. We want an interface where it helps me to back up automatically. This plugin helps you to back up your SQL Server database to Azure Blob Storage from the portal. That is the one which I showed you in the configuration. So this is the one, auto backup. You can enable auto backup during the provisioning itself, and it will take care of automated backup to your SQL Azure Blob Storage. This backup is only available till 2014. 2016 is changed the backup, the way the backup was done. So the 2016, this feature is not available, only up to 2014 from all the way to 2012. And you have automated patching. Same way, they don't want to patch the Windows manually, so they wanted an auto patching. This is a plugin which will help you to configure your patching scenario. It takes care of when do you want to patch, how long you want a maintenance window. It works closely with the Windows update patches and installs SQL Server critical patches, not all patches, only configured as critical. Those are the patches will be applied. So the HA, we talked about HA. You have three scenarios. One, within the same data center, you can set up always on within the same data center. You can set up one secondary on a different data center altogether. You can have somebody connecting from your on-premise world saying that, hey, I have SQL always on already. I want a DR as Azure VM, and you can set up that too. So these are the three different scenarios you can set up in always on with Azure VM. You have a complete steps process documented in this link. If you go through it, it talks about like a huge document which talks about step by step how to go and deploy always on from the scratch. Now, remember, you need a DC in the Azure in order for always on to work on 2014. So you can automate the whole thing always on using automated template. We have something called template. So if you click on this, it walks through the same deployment process it deploys everything for you. It deploys a DC, 2 DC controller, and it deploys 3 nodes, 2 SQL node and 1 failover witness, and you will have an internal load balancer already configured. So you will get a fresh always on already set up. You just need to go and restore your database and set up the database for you. Everything is taken care of for you. The one caveat here is it only deploys completely. You cannot join into an existing domain. At present, we are working on it on that. And SQL always on Azure requires a load balancer, something called Azure Load Balancer. We need to tie it out. And that again has a link here. You can access and follow the steps too. And you cannot bring your always on and on-premise environment and execute on to Azure VM. That's a restriction at this point of time because of various components involved in the Azure VM. So this is, we can do it. So we want to talk about what you will get in the futures of the Azure world. So we are planning to bring in a failover clustered instance for SQL Server. We want to bring in it, if you have an existing domain controller already and you want to set up an always on, we want to give you a template for it. And we want to publish everything in the template so that you can use the template. It's a GitHub, it's an open source source controller where you will be seeing all different templates for Microsoft, where you can use a template and you can provide certain parameters. It'll take care of deploying it for you. And we want to use the IIS extension for automated diagnostics so that it can come back and tell you, hey, your server is performing slow. These are the recommendations from us instead of you calling support to help you to troubleshoot a performance issue. And this slide, I'll share it with the administrator. He can share the slide. This slide will give you all the link, and I have added all the additionals in the content in the links, so you shouldn't be able to access all the things. So if you think about it, this is nothing but a SQL deployed on a VM. It's just that it's in the cloud. A cloud has its own limitations, like resource constraints. So you need to consider those resource constraints and deploy. And you need to also think about optimal performance deployment before you put it for production or even for testing. Because even for testing, if a test is not coming good, you will not be happy about it. So ensure for testing also you just use the optimal performance for your deployment. So if you think about it, you can bring your own VM. You need to do more configuration, and you can do an hybrid scenario. You need to know there are gotchas in terms of performance where you need to use a premium storage, you need to configure the premium storage and all those stuff. And there is ARM versus classic. So these are the different questions you will be asking yourself when you deploy. I have additional steps here in terms of how to bring your VM and all those stuff. You can go through the slide, it'll talk about it. Any questions? I know I didn't give you time to even ask questions. I don't know anybody had a questions. I'm ready to take any questions for you.
Okay, I do have several questions for you that they've come up with. So the very first one, at SQL Pass last year, I was told you should use premium storage for SQL Server and Azure production. The
Yes.
cost is based on total storage and not how much you use. Is there a more economical way of doing this?
No. At this point, it's just the Azure Premium Storage comes with through three offering, right? One is P10, P20, and P30, and that's the only option right now. And we are working in the background to come out with a much more granular approach, but I don't have any timelines yet. For now, this is the only options you've got.
Okay. Storage I/O performance is my biggest challenge in Azure. Can you talk of the same of the ways to get better I/O?
The first thing is you need to go to premium storage. And once you go to the premium storage, the first thing you need to understand how much of I/O you're looking for your SQL Server. Where you need to know an approximate number, not exact number. Let's say I want 15K IOPS. I want 20K IOPS. So you need to provision that disk respectively. Let's say if I have a 10K IOPS requirement, then I need to have a minimum of 2 P30 disks, which will give you 10K IOPS with less than 10 millisecond latency. And then you can pull it together of making a one logical volume out of it, which will ensure that your log file and data file are using the same path, and anybody who's pushing the limit will be able to manage up to 10K IOPS.
Okay.
That's one way to address it. The second way to address is, I am pretty sure based on my experience in the past 12 years, there are bad queries in your SQL Server, in the sense that the query is doing unnecessary reads, which can be optimized. That's another approach.
All right. Why not GS series? GS series are the highest performing boxes and support premium storage. Wouldn't you recommend GS for heavy reporting, real-time replication from on-prem to Azure, VM, heavy column store utilization?
Yes, if you think that you need a very heavy, intensive CPU bound operations, GS. But to keep in mind that is an expensive machine. That's GS is not like cheap. It's just definitely high cost. So if from a perspective of me recommending GS machine is subjective. If your workload requires GS, go to GS. If not, you can reduce your cost. The main reason we are coming to cloud is to reduce the cost. Now, my main objective to reduce the cost. That's why we're going to the DS series machine. Now, the one good advantage about DS series machine is you can associate up to DS14, which gives you a lot of CPU. I think it's 32 core CPU, if I remember right. So unless you see, hey, even DS14 is not giving me, then I will consider the GS machine.
Okay, can you talk about Azure database pooling and how do I estimate what I need?
Azure database. This is not a pooling available for Azure VM. The database pooling is for the Azure SQL database. That's a PaaS model you're referring to. That is for Azure PaaS model. There you can go and pool your, you can create a pool and put all your database in there, and it's kind of a container where you're setting a max limit for the container. Anybody can use that amount of resources at any point in time. So this is not the infrastructure service you're talking about.
All right, yep, you're right. That's definitely the other one. Can you speak about your experience with Azure Express Route as it relates to network latency?
Uh, the Azure network, the express route, right? I have, how do I put it across, many different high-end customers. Even within Microsoft, if you think about it, all internal departments, internal IT department, we do use Express Route. They have to subscribe to that. It doesn't matter whether they are internal Microsoft or not. So everybody who requires a less latency, I would recommend an Express Route. Now, I do not know how much of SLA in terms of express route is providing you. I do not have that visibility. I might be able to find and share that information to you, but I don't have anybody complaining that my express route is slow in terms of SQL workload concern. I've never had any customer calling me and say, hey, even though I have an express route, I have a latency issue.
Okay. You pay for premium storage because it is not shared storage, correct? Is it physically attached to the actual physical server where the VM is deployed, correct?
So no, the Azure storage is a distributed file system. Let me put it this way. There is a layer in between your hardware and your VM. That layer is a layer called distributed file system layer, which is exposing you as a VHD, as a disk, as a blob, or whatever you call it. That particular guy takes care of managing your IO to all the way to the physical hardware. Now, the physical hardware is not a one single disk. It's a distributed file system. The file actually stored in many different storage tabs. So it's not really attaching one SSD drive to your VM. No.
Okay, I've got about 8 more questions, and some of them look like they're going to be small, and others might be other. We'll see where we go. Say I'm
Mhm.
on storage tier, and now I see too much latency and want to migrate to better storage. Does that mean I need to buy new disk and migrate them, etc.? Or can you in place upgrade storage layer without any downtime?
So in terms of when you get a storage latency, that latency could be due to the type of storage type you have got, probably a standard storage, or it could be a premium storage. I don't know. But if you are trying to migrate from a one storage type to other storage account, it's end of the day, it's a file system. It doesn't matter whether you have to copy that file to the other storage account, else it won't copy. But I'm pretty sure there are features who are coming up in the future where it will help you to do the copy and do not wait until the copy completes. What I mean by is it won't be like if you have 10 terabyte of data file and you want to copy, might take like probably 5 hours, and you don't need to have 5 hours downtime. They are coming up with features where it'll help you to migrate your files from one storage account to the other storage account. It doesn't matter whether you're doing it for a performance reason or you're moving it for some other reason. They are trying to come out with a feature where it'll help you to reduce the downtime to copy the file. It's a physical operation. Let me put it that way. It's not a logical operation.
All right. If you've got time, we can get a few more of these
Yeah, go ahead.
questions in.
Yeah, go ahead. I'm open.
Can you talk about how we can measure current IOPS on a prod box? That is a site server or on-prem, and how to choose the disk on Azure will have enough I/O performance.
Hopefully you're seeing my screen.
Yep, still see it.
Okay, so my favorite tool is this. Okay, I'm not a third-party tool vendor or something like that. I normally depend on this guy. So this is a Perfmon. Now this Perfmon by default comes with a physical disk. If you see, there are different SQL. I'm looking for physical disk. Is it page file? Yes, physical disk. So you can go to your disk and say, hey, this is one of your drive on the logical disk, and if you see these my latency, what I'm talking about, these are latency counters. This seconds per transfer, read and write is my latency, and this is disk transfer per second is my IOPS. It tells me in this time of the frame I'm getting an average IOPS of 3 and max of 28 within this time span. Now what I would do is I'll go ahead and collect a collection set. I can define my own collection set, and I can I can do like perfmon. I can say, hey, get me physical disk counters for this guy and run it for like a week or so. Once you run it and stop and load it in the perfmon, and you will be able to see over a week how much of IOPS was performed on that particular disk. And that disk will tell you what is the range. It could start from 1,000 IOPS to all the way to 10K IOPS, depending upon how your workload is. Now that gives you the range. Now based on the range, you can estimate your IOPS requirement. Hope that answered your question.
Okay. The next question, are there caps on the I/O at the VM instance level? Amazon AWS has that. I was wondering if Azure does too.
Yes, it does. So that's what I was showing you earlier. So if you come down, you're still seeing my VM, hopefully.
Yep, still see it.
So let me go to the VM sizes, virtual machine sizes. So the link, we always try to keep the links in the same page where you can route to. So if you see, let me go to DS machine, right? Let's go to DS machines. So here, so the DS is the max of DS14, which gives you a core of 16 core and with a max of 112 gig. And if you see, this is the IOPS it can do. The machine level IOPS is 64K IOPS. It can do a 64K IOPS of max throughput. That's what it can do at the machine layer, right? This is uncached IOPS. This includes everything. This is uncached. Uncached means it directly goes to the disk storage subsystem. This is the max it can go. This is including the cache. This is excluding the cache. Now, remember, this is a distributed file system, so it has a max network bandwidth too. So you have 8 network card, and it has a very high level network bandwidth. Yes, you do have a machine level bandwidth and IOPS limit. And if you go to the premium storage, I'm clicking on the premium storage and I'm trying to go to the premium storage page for you, and I just want to show you that piece. So this is the premium tier I was talking about, P10, P20, P30, and it says you that P10 comes with 500 IOPS and you can only do 100 MB throughput. P20 comes with 150 MB throughput with 2300 IOPS. So whichever is the less on that specific VM, that's where you're going to get throttled.
Okay.
Hope that answers my question.
All right. Next one is SQL Server on VM. What happens if the data center would be destroyed?
You need to set up your own HA. You need to set up your DR from an infrastructure perspective. Your Windows VM will be brought. It doesn't matter. It will be brought. The reason it will be brought is that if it depends upon how you deployed your VM. Remember, in order to get your 99.99% LSLA, you need to have a high availability set. But if I go to this VM, this is a Windows VM for me. This VM has as set to the disk is perfectly set in this storage account. This is my storage account, and this storage account is defined based on what type of storage account. Is it a locally redundant storage account? Is it a geo redundant storage account? Depending upon what storage account from a Windows layer, you will be able to recover it. But even though you do a geo storage account from a SQL layer, it's a persisted application. So you need to set up SQL layer in order to handle those scenarios. So you need to have a DR SQL server on another data center, a DR like an asynchronous replica from an AlwaysOn to make sure your entire data center goes. You will have some application able to route to your DR site, and you'll be able to bring your database back online.
All right, well, that's going to be it for today. I appreciate that. I've got a couple other questions, but I'll just send them to you and let you answer them and send them back to me, and then I can get them posted up on our website for them. We did record this today, so we will have it up on YouTube hopefully by the weekend for you. And I will be sending an email with the link of the recording. Bali, I want to thank you again for coming today. Very, very informative. And I think our crew also found it very informative. So thanks, and we'll talk to you next month.
Thank you.